Today we are going to look at three main ideas of sampling. You would also understand the difference between population parameter and also sample statistics. And then we are going to look at various sampling designs. We always do receive, or most of the time, we always get surveys, even sometimes through phone calls. Sometimes you also get some questionnaires in our mails and all that. And even sometimes when it's getting to elections, you see people bringing out polls. This candidate is leading. How do they get those information? They get those information by what? Conducting surveys, right? Speaking to people. So that is what we are talking about. So when we talk about surveys or sampling surveys, and then now there are many ways to get a good sample. There are many ways to get a good sample. We are going to focus on there are three main ideas that you need to understand. The first one is examining a part of the whole. So the whole here is the population. And so examining a part, it means you examine some of the population. So the idea is to draw a sample. So to explain that better, the entire students in this class is the population of students in this class. Is that okay? If I want to find out your study habits and then I decide to pick 10 people from this class, those 10 people are the sample. Does that make sense? So they are parts of the whole population. Is that okay? So the population is the whole people, and then the sample is a subset of the population or a representative of the population. Why do we sometimes need a sample? There are many reasons. Sometimes, for example, imagine the university wants to conduct some research about students, and upstate we have about 21,000 students. Sometimes it's going to be very difficult to get all the students. So then it's very important that what we use the sample, some students. Is that okay? The other idea, and also one thing you also have to know is that sometimes sampling by nature tend to overemphasize some characteristics of the population or sometimes to underemphasize. For example, and then when you do that, that leads to being biased. For example, imagine you want to know about the exercise habits of people living in Boone, right? And then you go and pick your sample at the gym. What do you think? Is that going to be a fair representation? No, because most of the people at the gym are people who loves to what? Exercise. Is that okay? And so when you do that, you have what? You have been biased. Does that make sense? So sampling methods that overemphasize some characteristics of the population are usually biased. And so it's very important to avoid bias because if there is bias, it means that our conclusion is flawed or it's inaccurate or it's not a representative of what is really happening. Does that make sense? Good. For example, imagine I want to find out the average height of people in this class, and then I decide to select the tall people. Do you think it's a good representative of the average height of students in this class? No. So then that has been biased, and we want to avoid that. The other idea is to, if we want to select a sample, we should be able to what? We should randomize. So when we randomize, it helps us to what? Solve the problem of being biased. And then the last idea is the sample size. The sample size matters. Now the question is that what sample size do we need to be able to give a good reflection of the population? So the actual number of sample size also determines how accurate your results can be. For example, if I want to find the average height of students in this class, and I decide to, this class, we are about 31 or 32, and I decide to select 3 people, the sample size is very small, right? And so whatever I'm going to get, it's not going to be a true reflection of the average height of students in this class. Imagine you want to also predict the presidential elections, and then the US has about 340 million people, and then you decide to select maybe 100 people just in Washington. Do you think that whatever you have done is going to give an accurate prediction of the presidential results? No. So it means that sample size is very important. It is very key to be able to know these 3 ideas. Does anybody have any questions so far? So we are good. Okay. So it means that if any questions come or that you are being tested on these 3 ideas, you should be able to do well on them. So now the point is that some people also say, okay, well, then why bother? Why do we need a sample size? If sometimes the sample size is going to be too small, why don't we then use everybody in the population then, right? Well, that sounds good. So if you are using everybody in the population, that is like a census. You are counting everybody, right? But sometimes there are challenges with that. Imagine the US has 340 million people, and then you want to predict the presidential elections. It's going to take you a very long time to talk to 340 million people. So some of the disadvantages with census is that it is time consuming and it is also costly. And then sometimes to imagine you go to a home, you speak to people, and then maybe come to school. You could also be speaking to, when you go to the home, you could meet people at home and you come to the school. Some of them could be home and some of them could be in the school too. So sometimes there are a lot of challenges when you are dealing with the census. Okay. Now, these are some things that there are definitions you need to know. So, for example, the in this class, we have, say, 32 students, and then I take the average height of all the students. So the mean for that is going to be the population parameter. So population parameter, it's used to model for the what? The population. And most of the times, because it's very difficult to get the entire population, it's also, most of the times, the parameters for the population are usually unknown. And due to that, we try to rely on the sample. So for example, if I select 10 students from this class and then I find their average age, that answer is the what? The sample statistics. Does that make sense? And then say the average age is say 19. What it means is that that answer is going to what? We are extending that answer. It means that the entire average age of students in this class is about 19. based on the sample I used. Is that okay? So we make inferences from the sample to the population. Does that make sense? And then these are various statistics parameters that you should know. Usually, for example, if I find the average age of those 10 people, that is what the sample mean. And we represent that by, it could be X bar or Y bar. But for the entire population, it is mu. And so these are various symbols that they are statistics symbols that you, when you see them, you should know. You could create a table on them on your cheat sheets too. And then the standard deviation for sample is a statistic. So that is S for the population, it is sigma. And then for the others too is there. Now, we are going to talk about sampling designs. This stage is very important because in your homework, your quiz, and your exam, you would read problems and you should be able to determine what sampling design is appropriate for that. So the first one we are going to talk about is what we call simple random sampling. So for the simple random sampling, what it means is that each sample of the sample size has an equal chance of being selected. So I provided an example here. So in this class, we have about 30 students, and then I want to select 5 students to answer a survey. So to be able to ensure that everybody has a fair chance or an equal chance of being selected, I decided to write numbers on the slips of paper and then mix them in a bowl, right? And then I draw five numbers. And then I'll use those numbers to select the students. So that is an example of the simple random sampling. The other sampling design I want to talk about is stratified sampling. So for stratified sampling, it is in 2 stages. The first stage is to divide the population into a homogeneous group, and then that group is called strata. And then we use simple random sampling to select the sample within each stratum. So this is an example of that. So suppose a company has 1,000 working employees in 3 different departments. So 500 in sales, 300 in engineering, and then 200 in marketing. And then the company wants to select 100 people. So to select 100 people, to ensure there is a fair representation from each department. So you see, for stratified sampling, we have 3 departments here: sales, engineering, and marketing. And we want to select 100 employees. So to do that, these are the steps. We first divide the population into strata. So here we divide the population into their departments. Is that okay? So when we divide the population into their department, because I want to select 100 employees, I try to find how many I'm going to select from sales, how many I'm going to select from engineering, how many I'm going to select from marketing. Is that okay? Because their sample size for each of these groups are different. And so you can see engineering has 500, sales has 500, and engineering has 300, and marketing has 200. And so because I want 100 people, it means that I'm going to select 50 employees from sales, 30 from engineering, and then 20 from marketing. So to implement stratified sampling, I divide the population into strata. So here it's easy because the strata is what sales, engineering, and marketing. Is that okay? And then within sales, I randomly select 50 people. Within engineering, I randomly select 30 people. Within marketing, I randomly select 20 people. Does that make sense? So stratified sampling has two stages. We first divide the population into a homogeneous group. After doing that, that homogeneous group is called strata. And then within each group, we apply simple random sampling to select. Does that make sense? Good. Any question on this two so far? So does it mean that whenever you see an example, you can be able to differentiate between simple random sampling and stratified sampling? Okay, let's get to the third one. So the third one is cluster sampling. So for cluster sampling, we divide also the population into groups, right? And then that groups is called clusters. And then we what? After dividing the population into the clusters, and then we randomly select the cluster. So if each cluster is selected, we are going to use all the samples in that cluster. Does that make sense? Let's use this example to explain. So suppose a country has 1,000 schools, okay? And then we want to study about student study habits. So to implement cluster sampling, so instead of saying that, oh, let us select individually from all the schools, we want to rather use cluster sampling, right? So what cluster sampling is going to do is that we divide the population into, so for example, each school is a cluster. And then we randomly select some clusters. Say, so out of the 1,000, I decide to say, let me randomly select 50 schools out of the 1,000. Does that make sense? So when you select the 50 schools out of the 1,000, so the schools that you have selected, you are going to use all the students within the schools you have selected. For example, if you select maybe upstate, it means that you are going to survey all the students in upstate. Does that make sense? So the difference between the cluster sampling and the stratified is that we have groups, but with the stratified, we survey within each group and select some within all the groups. But for cluster, we rather randomly select some of the groups and then interview everybody in those groups selected. Does that make sense? So that is what cluster sampling means. And then the other one we want to talk about is systematic sampling. So for this one, it is a method where individuals are selected from a population at regular intervals. So we select the first one randomly and then every K individual. For example, if I want to implement systematic sampling in this class, I would say, okay, well, let me group everybody, let everybody line up, and I'm going to select the first person after that, then every fourth person after. That is what systematic sampling. Is that okay? So that means that those in the line, after randomly selected the first person, so imagine if I selected the fourth person, the next person will be the eighth, 12, 16. Is that okay? So that is what systematic sampling. Does that make sense? Okay. So this is also an example. If we have 10,000 customers and I want to survey 1,000 of them. So I determine the sampling interval. So for example, here K is 10. So it means that every 10 customer will be selected. So I randomly select the first one. So let's say the first one selected is number 7. It means the next person I'm going to select will be what? Number what? 17. Is that okay? And so on and so forth. So number 17, the next person will be what? 27, 37, because the K is what? 10. Is that okay? So that is what? Systematic sampling. And then also multi-state sampling. For this one, combine several methods of the what? Of the sampling techniques. Now, let's try to answer some homework problems. So we will do 3, 4, 5, 6. So I want you to read question 3, and then you tell me your answer and why. Can anybody try? Mm-hmm. Okay. Regular thinks is C. Anybody else?
D,
Okay, D.
because it's not like the entire like population, that's my right, it's just like the sampling frame like of that company.
Okay. So we have C, we have D. Anybody else? It is good to tell me what you think it's the answer. That way you learn. Is that okay? So anybody else? Okay, raise your hands. How many of you think it's C? How many of you think it's D? How many of you don't know? Okay. So let's do it together. So we are told that the company's annual report states our survey shows that 80% of our employees are very happy working here. Is that okay? And then you're asked to comment on that claim. Use appropriate statistics terminology. So when I look at this, then the first thing you have to ask yourself is the survey result a population statistic or it's a statistic? What do you think it is? So statistics means that like a sample. Is that okay? Does that make sense? And then the population statistic means like everybody. So what do you guys think? Is it a statistics or a population statistics? So we are told that it's a survey result. So it means that they spoke to some people, right? Some employees. So it means that that is what? That result is a what? A statistic. Statistics is for what? Sample. Is that okay? So it means that our answer is going to be between C and D. Does that make sense? Okay. Now let's get to the other one. So for example, if I pick these 4 people here and I find the average age, what am I trying to do? Probably I want to find the average age of people in this class. So whatever I'm going to get is going to infer on the entire population of students in this class. Does that make sense? So what this means is that this 80.01% here means that what? It estimates the true proportion of satisfied workers in the population. Does that make sense? You don't use sample and then get stuffs on them and then you infer on them. We use sample to infer on the population. That is why we are sampling. Is that okay? Good. And so I would think that the answer should be C. Let's see. So we are good. Let's get to 4. So read 4 and then you tell me your answer. And then when you tell me your answer, you have to be able to tell me why. I'm not here to do your homework problems for you, but I bring them up so that I try to see how you think so that you could be able to understand the stuffs better. So it's very important that you tell me what you think. Does that make sense? Good.
Like the selections will not be independent, like on the answer options.
So if the selections are not independent, it means that it's not really fair.
Okay.
It means that the chance of me selecting this lady, if I select this lady, it means that it has some impact on me selecting you.
Okay. So
Does that make sense?
yeah, cause like I'm looking at it like it starts out with like the random generated numbers. You would think that it's random sample,
Mhm.
but then they only contact people who got numbers divisible by 24.
Mhm. So what do you think? Do you think that is so simple random sampling means that everybody should have an equal chance of being selected?
Yeah, but if you pulled a number that's not divisible by 24, then you don't have a chance of being selected.
Yes,
correct?
because you are choosing some. You can't choose everybody.
Yeah, okay, so I would,
So if you are choosing some people and you can't choose everybody, you have to make sure that those people you are choosing, for example, if I'm choosing this guy, it should mean that I'm choosing him fairly. Is that okay? Not that I'm choosing him and it's going to impact this lady.
so would it be A?
So why do you think it's A?
Because, oh, wait, never mind, I'm probably read that wrong.
Okay. So raise your hand if what do you think?
It's, yes, it's a simple random sample. Each employee has an equal and independent chance of being selected because like in the definition of like what you said, simple random sampling wise, it says that each sample of the same size has an equal chance of being selected, so that's why I think it's that.
Okay. So that is C, correct?
Yeah.
Okay. Anybody else?
I
Mhm.
think it's B.
Why do you think it's B?
Because it's not random, like, they give random numbers, but since it's O indivisible by 24, it's not
Okay.
independent, it's not equal, so.
Okay. So I want to ask you a question. Say
Mhm.
I want to select 10 people from this class.
Mhm.
Okay. And then I generate some numbers and I say that, okay, the people who had 10 is the one that I'm going to select. Is that random or not random?
Mhm.
Why? I want to select 10 people from this class.
Mhm.
Okay. I generate some numbers.
Mhm.
Okay. And those numbers are assigned randomly.
Okay.
And I say that, okay, those people who are 10 is the ones I'm going to select. Right? So are those the people who are 10, are those people, is the process random or not random?
Oh, yeah, I guess it is.
It's random.
Mhm.
You agree that it's random. Why is that random and that's not random? Like, I just want us to think. Does that make sense? I get what you're saying, and I'm just trying to say that, okay, this people are in this class. I generate some random numbers, okay? And then I randomly assign them. And I'm saying that, okay, I don't want this. Okay, let me pick it. Okay, I say, okay, then those who had 10 is the one I'm going to use. Is that process random or not random?
Random.
It's random. It's the same thing here.
Okay, so the answer is C.
The answer is
Okay.
C. Does that make
Because
sense?
Everybody does have like an equal chance to, I guess.
Yes,
pull
everybody
a
have,
number
yes, pull a number to be
divisible
divided by 24. Does
Okay.
that make sense? Everybody has an equal chance of pulling a number divisible by 24. And then the process of assigning those numbers to is random.
Okay.
Does that make sense?
Yes.
Sample means that I'm going to choose some. I can't choose everybody. But I have to make sure that that process is equal and fair for everybody. Does that make sense? Good. And then let's get to 5. So read through 5 and tell me your answer.
Cluster sample.
Okay, he's saying cluster sample. That is C. Adeline, what do you think?
I think it's cluster sample also.
Okay. Anybody else?
I'd say cluster sample as well.
How many of you agree it's cluster sampling? Okay. So let's see. Yep, that is good. Do you know why? Who doesn't understand why it's cluster sampling? So cluster sampling means that you see they divided, when you read the problem, several DOMs, and then they select the DOMs at random, and then so the DOMs, then they contact. So for cluster sampling, they group, then select some numbers of, like, for example, I have 10 groups. I select three groups. Is that okay? And then with the 3 groups I'm going to select, I'm going to contact everybody in those 3 groups. Does that make sense? So that is cluster. Then how about B?
Is that stratified?
Okay, so he's saying that is stratified. Anybody else? Why do you think it's stratified?
Because like in the example you gave earlier, it kind of broke it into like groups. Like I need, so many from this group, so many from this group, so many from this group. The only difference like I see here is like they're all 300 versus like with the one you showed, you had like 50 from this, 30 from that, like
Okay.
20 from the next. But
Yeah. Do you all agree that it's stratified? Yeah. How about the last one? He's saying systematic.
I
Why do you think it's systematic?
First selected randomly, and then it was every 60th one after.
Good. So here K is what? 60, right? So you see this, it's very clear to be able to see the difference, right? Let's do the last one, 6. What do you think 6 is? Okay. Anybody else? Okay. So you all agree it's cluster? Okay. So the manager select a single branch at random. So here the branches are the clusters, right? The various branches are the clusters. And then they randomly select one branch. And then for cluster, when you select the cluster, you would you talk to everybody there. Is that okay? So you see and survey every employee of that branch. So then that is cluster. How about B?
Systematic.
Systematic. Okay. How about the last one? Stratified. Okay. Yep. So that should be